Hello! In this video, we are going to prove the following theorem. For all integers n, if n is even, then -1 to the power of n is equal to 1. And if n is odd, then -1 to the power of n is equal to -1. Now, to prove this theorem, we are going to be using the following preliminary results. Our first result is, for every integer n, 1 to the power of n is equal to 1. Second, if a and b are non-zero real numbers, then for all integers n, ab to the power of n is equal to a to the power of n times b to the power of n. Our last result, let a be a negative real number. Then for all integers n, if n is even, then a to the power of n is greater than 0, and if n is odd, then a to the power of n is less than 0. Okay, so now let's get into proving this theorem. To start out the proof, let's give ourselves an arbitrary integer n. And something that we could do is the following. We know 1 to the power of n is equal to 1. So we have this, but let's re-express the 1 as -1 times -1. Well then, according to our second result, this is just -1 to the power of n times -1 to the power of n. Or you can think of it as -1 to the power of n squared. So then -1 to the power of n squared minus 1 is equal to 0. But we know that we could re-express this as -1 to the power of n minus 1 times -1 to the power of n plus 1. So -1 to the power of n minus 1 times -1 to the power of n plus 1 is equal to 0. So either -1 to the power of n minus 1 is equal to 0, or -1 to the power of n plus 1 is equal to 0. And therefore, either -1 to the power of n is equal to 1, or -1 to the power of n is equal to -1. Now, what happens if n is even? Well, according to our final preliminary result, -1 to the power of n will be greater than 0. But since -1 to the power of n is equal to 1 or -1, and -1 to the power of n is greater than 0, the only possibility we could have is that -1 to the power of n is equal to 1. That's it. This shows if n is even, then -1 to the power of n is equal to 1. On the other hand, if n is odd, well then, according to our final preliminary result, -1 to the power of n must be less than 0. But again, -1 to the power of n is equal to either 1 or -1. But since -1 to the power of n is less than 0, we must have -1 to the power of n is equal to -1. That's it. This shows if n is odd, then -1 to the power of n is equal to -1. So we have proven both of these implications. So this completes the proof. And so yeah, that's pretty much it for this video.